Hello everyone and welcome back to the another tutorial in the tutorial series simulating your custom robotic arm in ROS Noetic. In our previous tutorials, we had seen how to spawn the box model in our ROS environment as well as our Gazebo environment, and we had seen how to attach this box to our ROS robotic arm model, but we were not able to attach the box, this blue box, to our robotic arm in Gazebo. So for this, we need to write a new Python script that we will see in our today's tutorial. But before we write a Python script which will attach this box to our robotic arm in Gazebo, we need to do some basic preparation. So first of all, you need to download this file that I have provided in the video description. So the first thing we need to do is we need to copy this Gazebo ROS link attacher package in our Catkin workspace, because this package provides us the basic things that we need to attach the objects to our robotic arm in Gazebo. This package is provided by PAL Robotics. So first of all, we will copy this link and we will paste it in our browser. Now to copy this package, you need to scroll down, and here we don't need to follow these commands given here because it creates a new Catkin workspace. So first of all, you only need to copy this command, git clone, and the URL of this package. Then you need to open your terminal, then go to your Catkin workspace and press enter. Then go to the src folder of your Catkin workspace and press enter. Now you need to paste that copied command here and press enter. Now this will clone this package in your Catkin workspace. So type the command ls and press enter. So as you can see, the package is copied here. So before we build our Catkin workspace, we need to modify some things in our RobotArm URDA package. So let's dig into that. Now we will open our Catkin workspace. So I'm working in this moveit underscore ws workspace for our robotic arm simulation. So I will open that. Now we will open the src folder. And here you can see we have copied the Gazebo ROS link attacher package. I will brief you a little bit about this package. So you need to open this package. So here you will find this include folder where we have this Gazebo ROS link attacher.h file defined. If you open that, you will find here some plugin is written here, and it is written by Sammy P. Pfeffer. Sorry if I have pronounced the name incorrectly. So in this file, they have created this Gazebo link attacher plugin. So you can explore this a little bit, but here I can see like they have created one node handle. Then they have created the service servers for attached service and detached services. And here they have prepared some callbacks. So I will not dig into this a lot. You can read this file. Then if we again go back here, we have this src folder where we have this Gazebo ROS link attacher.cpp. If you open that, so here they register the plugin with the simulator. Then here the constructor is created. Then in the constructor, they have created this node handle, the node link attacher node. Then here is the destructor. Then here in this function, they have here basically advertising the services that we will use to attach and detach the box from our Gazebo simulation. Here you can see they are starting this attach and detach services. I will not explain this code in very detail. You can read the code on yourself. Now we have copied this package to our Catkin workspace. Next in the package, here we have one word given. If you open this word file, here you will find they have defined a word file. So in that, in this word, they are loading this plugin, which is this ROS link attacher plugin, and the file they are loading is this Gazebo ROS link attacher.so. So our next task is we need to load this word in our robotic arms launch file. So I will close this file. Now open our file browser, and you need to again go back to the src folder. And next, what you need to do is you need to open this launch file available, this arm underscore urdf launch file available in your robotarm urdf package. So we will go there and we will open this robotarm urdf package. Then we will go to its launch file and we will open this arm underscore urdf.launch file. So here what we need to do is we need to first add these arguments at the beginning. So copy these arguments and go to this file, and you can add them after this already available arguments. you can indent the code a little bit. Next, you need to find the line which includes the empty gazebo word. So this is the line. So we will take it little separate. Now we need to replace this line with some another code of lines. So you can open this file, and here, as you can see, you need to find this line and you need to replace it with this lines of code. So I will copy this and I will replace this line with the copied code. And I will remove this repeated comment and a little bit of indentation. So basically here we are launching this empty gazebo world. Then here we are passing the world name as this test attacher.world file from our Gazebo ROS-link attacher package. We are setting this debug value, which is available here, to false, the GUI value to true, the paused value to false, the use sim time value to true, the headless value to false, and the extra Gazebo arguments we are giving as verbose. And rest of the things will be remain same. Now we will save our launch file and close this launch file. Now we are ready to build our Catkin workspace. So again, open the terminal here. Now type the command cd and your Catkin workspace name and type the command catkin build and press enter. Your Catkin workspace should get built without any errors. It may show some warnings. And if you again build the Catkin workspace, the warning should go away, as you can see. Now, to test if we have successfully installed the Gazebo ROS-link attacher plugin, we will launch the simulation of our robotic arm. First, run the setup.bash file of your Catkin workspace. So type the command source devel/setup.bash and press enter. Now, start the ROS master. So type the command ROS core. Now the ROS master is running in the new terminal. Again, if you are not in your Catkin workspace, type the command cd and your workspace name after the the home symbol and press enter. Now again run the source file and press enter. Now type the command ROS launch, then your manipulator package name that we had created in our previous tutorials, and type the launch file name, which is the full robotarm sim.launch, and press enter. And it should load the RVH simulation as well as the Gazebo simulation without any error. So as you can see, my RVH and the Gazebo have started successfully. So there is no error in the launch file. Now to make sure everything is going good, you need to open a new terminal. Now we need to confirm that the ROS services created by that Gazebo ROS-link attachers are published or started successfully. So now type the command ROS service space list space slash link underscore attacher underscore node and press enter. So as you can see, we have here two services available, like link attacher node slash attach and the detach. So this means that we have successfully installed that ROS link attacher plugin by copying this Gazebo ROS link attacher package in our Catkin workspace. Now we are ready to write a Python script which will allow us to attach the boxes to our robotic arm in the Gazebo environment. So that we will see in the part 2 of this video. Thank you so much for watching this video. See you in the next tutorial. Bye.